as we talked about in class, we talked about the notion of effect size, and that we're looking not only to find out whether or not the difference is statistically significant, but whether the difference has some level of meaning. And so if we take the data that we ran for the t-test demo, the median age in Michigan, the median age in Wisconsin, one of the things that we found was that the data was not significant. And so that was just fine, but what I want to do is I just want to show you how to calculate that. And there are lots of handy calculators on the net. And so the one that I like a lot, and although I have another one on the sheet as well, is this Psychometrica. And if you go down the list, what you just did in this example was you compared groups with different sample sizes. And what we're looking to do is calculate something called Cohen's d or Hedges g. They're the same statistic, but they have different names. And I've already plugged in the data values here, and it's calculated this automatically. There's nothing more boring than seeing someone actually calculate data values. And so you can see how this works. I'll type 83 back in there, and it calculates it out again. So we have an effect size of -0.2, which means we have a small negative effect. And if we're looking at some kind of confidence interval, we're pretty sure that the effect is somewhere between -0.5 and +0.1. So reasonably certain that there's at most there's a medium negative effect probably going on. But remember, our results are not significant to begin with, but I want to demonstrate that you can calculate it this way. The other thing to note is that there are other effect size calculators depending on what you're using and what statistical test we're using. We're going to play with those later on the semester, but I wanted you to see these and get going with effect size right away and have effect size be part of how you talk about your data.